So that is going to be open circuit to time constant method. So it is very simple. And short circuit time constant, as I said, the concept is going to be same, and it is going to estimate the low frequency point. So remember, OC is going to estimate FH or FU, higher cutoff frequency or upper cutoff frequency, whereas short circuit time constant are going to estimate the lower cutoff frequency, FL, or it is going to be F lower. So I am leaving the reading of short circuit to you, and just remember, it is going to have N zeros and N poles. So it is going to have N zeros and N poles, but for open circuit, the zeros were not there. So this short circuit involves the presence of zeros in our transfer function. Okay, so I'm not going to explain this and say, you can see the theory portion will be very, very similar compared to your open circuit. So just have a reading, and any doubts, same the steps also you see, the same way you have the steps to compute the short circuit time constant. And finally, if you add all the time constant values and reciprocate, you get the lower order estimate of your lower cutoff frequency. So that is what an explanations are given here. You can please read this and ensure that you don't uh, get any confusion or assumption in the concepts. Okay, very, very important, OC and SC time constant. And finally, the bandwidth estimate using SC is given. It is 1 by tau into root of n. N is going to be the number of amplifiers in cascade. So if I'm going to cascade the amplifier, the bandwidth will reduce, the gain will increase. So how much it is reducing? It is given here, bandwidth equal to 1 by tau into root of n. So it reduces by root of capital N. And that is what is given. And one technique used for increasing the bandwidth at low cost is shunt peaking. So these OC and SC methods are estimating the bandwidth. Practically, how I can increase the bandwidth of an amplifier is by a method called shunt peaking. So shunt peaking means it is going to be, I'm going to add inductance to peak the frequency response